Hello all, welcome back to the data science. In this session, we're going to start with Numpy. What exactly is this with Numpy? Why do we require to use this Numpy package? And in what way it is going to benefit us in the data science as we develop any model? What exactly is this with Numpy? First of all, let me tell you, Numpy actually is a package to build, create, organize or perform the operations on the arrays. Simple, it's going to provide you a framework to create and organize the arrays, right? Now, already we know this. But why do we require to use these arrays? Is the first and foremost question, since we already have the data structures very similar to the arrays in Python. Python actually provides you with some data structures such as lists, dictionaries and tuples. What encourages us to use this Numpy package rather than lists, tuples or dictionaries? We just are going to understand in this session. First of all, let us talk about Numpy. In the previous session, we already discussed about data science and the various techniques or tools that are required and to understand in data science. In this session, we're going to start with the Numpy. What is Numpy? By the definition, it goes, the abbreviation states that it's a numerical Python. It's a numerical Python. It's a Python package for n-dimensional array. You will be able to create and organize and perform any complex operations on one-dimensional, two-dimensional or any dimensional, n-dimensional array, which is an ND array object. What exactly is this ND array object? We are going to understand. Now, provides an array and supporting mathematical function. Right after you create the array, you don't require to write the functions to perform the operation. Mathematical operation, for any mathematical operation, we don't require to write our own function, define our own function. Numpy package itself is going to provide you a lot of predefined functions through which we'll be able to perform any complex mathematical operation very easily indeed. It's an array of multidimensional uniform collection of elements. The first difference we are going to list out. The first difference that we are going to understand is in between the Python list or tuples and the Numpy arrays is, in the Python list, we'll be able to collect the data types, rather the elements which belong to the different data types. In the other words, list is a collection of the data elements that belong to heterogeneous data types. It is one of the disadvantages whenever we use a data set in a data science. What exactly is this disadvantage? We're going to understand in the upcoming sessions, but here we just need to understand a Numpy array is a kind of an array, is an array which is going to be a collection of the data elements belong to the same type. It is not heterogeneous, it is the homogeneous data type elements. And the next thing is, arrays are characterized with data types and shape. The shape of an array is a tuple of integers giving the size of the array along each dimension. When you create an array in Numpy, it just is going to hold some data type and some shape. What is the data type? Generally the data type, obviously the data type is unique. The data, what you're going to store, the data type that you're going to use in a single array should be the same. If it's an integer, it has to be integer. If it's a float, it has to be the float. You cannot change the data types. Right after the data type, the next thing that we need to understand is its shape. Every array is going to have a shape. What exactly is the shape? Maybe a 2 into 2 array. What is a 2 into 2 array? It will have 2 rows and 2 columns. So an array is, a shape is a tuple of integers, such as 2 into 2. That's what mentioned here. It's integers giving the size of the array along each dimension. 2 is, if I say 2 into 2, 2 is a row and 2 is a column. And in addition to which, we'll also be able to specify the axis. In one-dimensional or in two-dimensional, in three-dimensional arrays, we'll also have one more thing called axis. That also will be represented by a number. 2 into 2 into 1, meaning we have a 2 into 2 array in one-dimensional array. Rather 2 into 2 in a two-dimensional array. 2 into 2 into 2 in meaning we have 2 dimensions, 2 rows, 2 columns and there are 2 elements in each row, which is going to describe the column. Arrays in Python can only contain values corresponding to the same data type that we discussed. Next thing is provide support for handling large multi-dimensional arrays and matrices along with a wide variety of mathematical function to operate on these arrays. As we already discussed, as I already told you people, that Numpy is going to provide you the built-in functions through which you will be able to perform any complex mathematical operations. You don't need to define your own separate function for any mathematical operation. Right from the very basic functions till Fourier transformation, you will be able to perform any complex operation by simply making a call to the inbuilt function. The next thing is Numpy arrays match faster than Python lists and dictionaries for the large data sets due to their implementation in C, which avoids the overhead of Python loops. Now, there will be some disadvantages with respect to the lists, with respect to the, what is this, lists and the dictionaries. What is the disadvantage with the lists and dictionaries over Numpy arrays? Rather, what is the advantage of the Numpy arrays over the lists and dictionaries? First of all, Numpy arrays are much faster. Whereas lists and dictionaries, since those are inbuilt functions, inbuilt data structures within the Python, they are not as quicker, they are not as faster as a Numpy package. Why? Because the fundamental difference is in between Numpy array and a list and a dictionary is, when it comes to the list will not be stored in a consecutive locations. List will be stored in a different locations in the main memory. Every element, let us say I do have a list which is of 100 elements. All these 100 elements, for an example, this is my memory. This is my main memory. I just have created a list with 100 elements. All these 100 elements of the list will get scattered across the entire memory. You don't know which element is going to get stored at which location. To access any of these objects of the list, we should have one more pointer. So this is what the worst thing with the list or a dictionary. Every list should also have one overhead. What is overhead? It's pointer. For an example, I do have 100 elements. I stored 100 elements. Rather, I created a list with 100 elements for which there has to be a block created. You don't know. You don't have any detail, any transparency to the block that is going to be created in addition to the list you already created. Python itself, Python interpreter is going to create one block of pointers for the list that you have created. That means a list of 100 elements will have a block of 100 pointers. Each pointer is going to point one object or one element in the list. All these elements are scattered across in the memory. So that's the very reason why we require to have a block of pointers. So this is the fundamental difference. A list, all the elements of the list rather are going to get scattered across the memory, but whereas when it comes to the Numpy, all the elements are going to be grouped together. All the elements will get stored in a consecutive locations. This is an important thing, so that by indexing we'll be able to access any element very easily and more faster than list or a dictionary. And more importantly, Numpy package uses C implementation. C implementation is much faster than the Python implementation. So in any possible way, Numpy packages are faster and better than the Python list or dictionaries. Now, whenever you want to perform an operation on elements on the list, for an example, you want to perform some vectored operation, what you just need to do is, you just need to loop them through. In order to perform the operations on each and every element on the list, you should need to use a loop. For an example, all these 100 elements must be incremented. What I should do, first of all, I need to take a loop, and then in the loop, I need to define the logic, because I just am applying some logic which is uniform to all the elements, right? For that, here I just need to use a loop. Okay, but Numpy supports vectorized operations. Through the vectorized operations, we will be able to avoid the loop. You don't need to use any sort of a loop. Rather, Numpy package itself is going to provide you the vectorized operations such that all the elements can simultaneously be updated the way you want without using any loops, which saves a lot of time. And the next thing is Numpy arrays consumes less memory than Python lists. There is one particular interest behind using the Numpy arrays over a list, because it's just going to consume less memory. As I already told you, with respect to the list, there should be a block. There should be a corresponding block which contains the pointers, right? The pointer itself is going to add a lot of overhead, right? So here, let us understand what exactly is the overhead for the list. all the elements of the list. Now understand carefully. When I talk about a list which is of 10 elements, we already knew that each and every element may be of different data type, right? Because list is going to be the collection of heterogeneous data types. Heterogeneous elements belong to the different data types, right? Now, I have a collection of lists, that is 1, A, and 10.4, Anil. Okay, now I just have a single list in which I have an integer value, a character value, a float value, and a string value. Each of these elements belong to the different data types. Now I do require to store additional information. It just looks like this. The first element, I do have 4 pointers here, first pointer, second pointer, third pointer, and a fourth pointer. You know that there is a block of pointers from which all the elements will be pointed to. Now this first pointer is going to point to the first element. What is the first element? First element is 10. But the 10 is of which data type? This 10 is of an integer data type. So the metadata, rather the detail of this information will be stored in some other word. Okay, this 10, the metadata, that is the actual details of the 10, that is the data type, integer, will be stored in another block, rather in another word. And the size of this integer will be stored in another word. Okay, this 10 is an integer. Since it is an integer, it must be stored in a separate word. And since this integer is of a specific size, this also will get stored in another word. So I require a pointer in main memory for one element. I require a pointer, this is one word, actual object which contains a value 10, that is the second word, and the third word is the data type, and the fourth word is the size of the data type. For one single element, I require 4 words within the main memory. You just can imagine, as the size of the list is getting progressed, what could be the total size that is going to occupy in the main memory? It just takes a huge overhead. Where in Numpy, although we have a little overhead, it is not as much as the list. Numpy will consume a very less memory as compared to the list. List store the elements objects with metadata type, with references, etc. Whereas Numpy array store the data in a contiguous block of memory with a fixed data type. As I already told you, list store the elements and the objects with metadata, that is the type, reference. Of course, as I told you, there will be a pointer. As I already told you, for a list, there will be a pointer for one element. I am just talking about. Pointer, object, D type, and a size. This is the metadata. Okay, pointer, data type, and size is the metadata which is related to the object, right? But whereas in Numpy, the total, all the elements will get stored in a contiguous locations. So let us say this is a Numpy array in which this total array is going to be of a single data type, 1, 2, 3, 4. Now here, I don't need to store the pointer with respect to every element. Rather, I just do require to have a single pointer with respect to the entire array, right? I just need to have an offset, the first address here. Let us say this entire array is starting from 250th address. So I require only one pointer which stores the first address of this entire array, right? This is the advantage, the main advantage, the fundamental advantage rather of Numpy array over a list.